Oh, so good morning. And thank you for inviting me at this session. So I will speak about career opportunity at ST, but I will try to do it in a special way. uh, Starting from the company and going to the division, then to a site. To show you which kind of job you can have, first part of the presentation, and second part, what we are doing now to resolve the big problem we have with 4.0 industry. Okay? And this is something we have for a long time, so I will speak about understanding the culture and functional area within the industry, and identifying the best practice for making successful transition from academia. And you will see that this is not only from academia, and also inside the company. So first I will introduce a little bit my career. I am from physics, astrophysics. So I turned bad. No. So I moved to industry. So physics. And you will see that I will try to explain that science is not only science of nature. Science is human. From nature and spirit. If you separate both, big problem. Okay? So you will see that. So it takes time for me to understand that. I start in a startup in 91 in semiconductor industry near Rousset. And then this startup was merged with other company, and I was at the startup of ST, which was not ST before. My badge is 548, I think. And we are around 45,000, and we were 55,000. So I have seen this company growing, and it was like a startup with manager working like startupper. I start 6 factories, okay, in different countries. So just to show you my career, and then I was engineers and department manager, work in R&D, in manufacturing, in different places, even in design. And today I'm chairman of the board of technical staff college of ST. I'm a philo company, you understand, expert of experts, and I'm specialist in advanced process equipment control and knowledge management. Strange, knowledge management in okay. So I explain why. And I have two parts, still 2 parts. I still do consulting in plasma physics in some fabs, and at the same time, I'm working in a transfusional position on problem of knowledge management, how to make science on the field. So first, this is a summary of my presentation. What do you see? You see people, okay, or you see an object, okay. So if you want to build this object, okay, you need people. And perhaps we don't see the same thing. Okay? We prefer to discuss, other people want to start by the object, okay? And there is a big chance that we don't understand each other if you want to build this object. Okay? And this chance, you will see, we measure it, is between 70 and 90%. Okay? 2 people working together in the same room. Okay? And that's a big problem. So we will finish by that. So who we are? I will start by that. Then I will see the crisis we have seen from the year 2000. And my colleague from Peugeot explained things that we have seen in the past. Okay? And we were obliged, because ST is in the world of 4.0, meaning technological work, industrial revolution, this is 1.0, industrial revolution with computer, 2.0, robotization 3.0, and today, interface between robots and people. Okay? And in our plant, this is catastrophic. Very difficult. Okay? Very difficult because how to share knowledge, how to share competency when you have object in the middle like that, things moving very rapidly. And I will not speak about 4.0. I will speak about 4.x. Because the more we introduce interface between people and machine, the more we discover that we have a big human issue. And we have a destruction of the competency. Okay? So, I will speak about that, and especially the art of dynamic competency management and the transition from innovation genesis to industrialization. And then I will conclude with some recommendations for making successful transition from academia to the industrialization. So, product. You have device everywhere. So, ST today is providing device for all the market. The ST application strategic focus, two big parts, Internet of Things and drivings. Okay? This is the strategy of the company. We are not anymore in reducing the size of the transistor, okay, 7 nanometer, 14. We do, if there is an interest, but today we are still at 22 nanometers, and we don't invest at this time to reduce more. Okay? Our market, this is not our focus. So, it's a global company, okay, big growing, coming back, okay, we had a bad period in the past, and today it works quite well. And we have research center everywhere in the world, okay. We have front end. Front end is where we do the device, and back end when we do the assembly of this device, okay. And 45,000 people, 7,000, more than 7,000 person in R&D, 11 manufacturing sites, and selling. So for my example, following what was said by our colleague, I used to work in US, in Italy, I used to work in Singapore, and a little bit in Asia. Okay, so I participate to a fab startup in Singapore and in Italy. Okay, so if we look the technology of ST, we have two ways to improve our product. If we look to this way, miniaturization, the size of the transistor. Okay, and today we are starting to look to quantum computing, molecular electronics, spintronics. This is the size of the device. Why? We call that silicon on chip. This is good for information processes, digital content, system on chip, densification. But there is another way to improve the quality of product, is what we call system in package. The capacity to put in the same device analog RF, passive component, power, sensor, biochips. And this is for interacting with people and environment, non-digital content, and system in package. Okay? So ST tried to merge both. Okay? The added value of the product is here. So, if we look the kind of contribution of a site like Kroll in R&D technology, this is the domain of technology we have in ST, and a specific site like Kroll is working mainly on this subject. Other sites in ST, if you are going in Italy or in other place, you will have other subjects. We are already doing R&D on packaging. Okay? So, it's impossible for a company like us to survive if we don't have very strong relationship with the university and European programs. Okay? So I was in charge of different of them, of program, European program. Okay, so we have European program, Eureka cluster, other kinds of cluster, strategic program, local strategic program, national programs, and okay. So that's an advantage, and that can be a big inconvenience. So we have a big pressure from the environment to do what the environment wants. Okay, so sometimes it can be good, sometimes it can be difficult, because if you are pushed in a direction which is not good, your company can be killed. Okay, that was the case 10 or 15 years ago. Okay, today that changed. And doctors, very important. My colleague explained that before. This is, I just put France, but this is example of cooperation we have with laboratory, specific relationship, 132 PhD on ST site a year, okay? And this is key for us. And why? Because with this, we have a very good relationship with the university, and we can learn, improve our competency, okay? And then with this very close relationship, we also support research, which is good for us, okay? So, it's included, for example, in my job, okay, to be a representative of ST at PhD school in Grenoble and in other place, okay? We have specific time to do that. So if you look to now more locally, and this is the same thing in Milan, in Agrate, in other place, okay, we are surrounded by, of course, in Kroll, we have a big facility place, which is an R&D center, but this R&D center is at the same time 30% of the production of the company in terms of device. So we are not doing R&D like that. We are doing R&D in the line where we produce, okay? Because the lifetime of our product, 6 months. Technology, 2 years. Today, a facility like Kroll is 106 products per year. 80% of the production is performed on 30% of this product. You see? So everything moves all the time. So we can't have an R&D waiting for production later. Okay? So we need to be in a very dynamic approach, because we are in the 4.0 world. Okay? Then we are surrounded by very nice center. Okay, so Aleti, we have other cooperation outside France, but Soitec, you know Soitec perhaps, Silicon, okay? And we have PhD from UPFL, some, okay? And this is a kind of career fields that you can have in this area. Activity, product development, prototype assembly and test, marketing. You have 2,000 employees in Grenoble. On Kroll, technology R&D and development platform, okay, production. So production here is R&D. We are doing industrial engineering in flow manufacturing, in with supplier of equipment, okay. So there is R&D in all these fields, okay. So if you look now, the kind of profile you have to make this factory working, this is not true that we have only scientists, nature of nature, okay? We need people in manufacturing operation, industrial engineering, okay? Of course, technology and design, we have product group, but you have support function. And I will speak about that. Human resource, site service, quality, ICT, and there is no way to work if you don't have competency in this domain, okay? And the ability of a PhD and an engineer to be able to work with these complementary skills is very important, Okay. So this is a global picture. Now I will enter more in details about R&D and manufacturing in high mix techno products, high and low volume. Sustaining functional evolution, creativity, innovation, and scientific practice. And I will explain especially why a big company with a lot of money is not able to have internal startup. Okay? When things are moving so rapidly, every product, every 6 months, technology every 2 years, you need to do something. Otherwise you are killed. Or your employees are going outside because there is no sense. Okay? So that was the key point in the 10 last years for us. Okay? And we find now, finally, perhaps an issue for that. And we are working very hard on this problem. And quality management system and dynamic skill management. Because when you change the product every 6 months, and you have PhD everywhere, and you introduce these skills inside the company, their knowledge, their skills, their competency is not in the culture of the company. And we have seen that 80 to 90% of good ideas are put to the basket, okay, only because people are not able to receive. We measure that 80% our R&D, good idea, are already here, but we are not able to work together to make them a product or something new. Okay? So the idea of finding things which are completely disruptive is completely wrong. What is disruptive for me is sometimes something that somebody else understands very well, but I am not able to receive. Okay? So, we are working with people, business, and environment. Environment, you understand, this is not only local, this is university, government, and things like that. So, I will use some specific terms. When I speak about knowledge, that means that one person or a group of persons have understood the cause to effect link. When I speak about concept, it's because one people or different people don't understand this link. Okay? I don't have this cause to effect. That's a definition. Okay? Which is coming from a theory that I will come. Seca theory. FMEA, failure mode and effect analysis, very popular tool in the industry. Quality management system and knowledge management. So, when you want to go from manufacturing to design for manufacturing, first you have your product. The more product you have, the more device. The more device, the more type of wafers to produce. This is a function of the product. One thing very important, you can measure if it's good or not. If that works or not. You can measure physically. Now to do that, you need another function. The tool to make the product. And there is two kinds of tools. The manufacturing tool, you can measure if it's good or not, how many wafer you have performed and things like that. And the equipment tool. The machine who does the process, the measurement tools, the IT system and things like that. Everything is measurable. You can make science on that. This is 4.0 world. Technological world. There is one word which is one function which is not measurable. You just measure the effect after is people. The function of people is very important because there is two aspects. The knowledge, they have to understand the cause to effect, and the competency, which is completely different. You can do something, have the competency, and don't understand exactly why. the majority of what you do, when you realize something, perhaps you understand, but when you are accountable or consulted or informed, this is not true. Okay? The added value of engineer is the complementarity of their skills. Second thing, you measure the effect of that later. If your tool is not working, your manufacturing line doesn't meet the function or the activity or the product. Okay? So, that means that if you want to manage quality management system, making working people together, you need to understand the system function and knowledge. And the problem you can have is a skill spread out. The more product you have, the more competency you have, especially if you are high degree education people, you are sure that after 5 minutes, they have an idea, and this is a Babel tower. Okay? We measure that in the same group, maintenance people, making a procedure. After 6 months, nobody understands the same thing in the document. Okay? Especially if things are moving all the time. Okay? So, the problem is, the more product you have, the more impact you have on the function of product, of course, but also on the function of the tool we are making the product. For example, if you are doing chemistry or plasma physics, you know that if you have a wafer, or you don't know, you have resist on a wafer, you put in a plasma machine, the polymer will go on the wall. As a function of the density of the product, you will not have the same quantity of polymer. Meaning the cleaning is not the same, the maintenance is not the same, everything moves. You see? But you can have one machine per product. So each time you change something here, you change the function of the tools, and you have an impact on people. If you change the screen in front of people, you need to change the skills of the people. Is it clear? That means that some people have worked a lot on that, and they say to manage that, you need to understand what is the function. And there is a very good guy to do that, Kant. Kant is a guy who defines how we do science. Okay? And he says that the unity of action, which order various representation under a common one. I will give you an example. If I use the name telephone, this is the same name for everybody. We need to precise a little bit more, because first, do we have telephone who are doing the same actions? I don't think so. Okay? This is exactly the spirit of this sentence. If you want to define the function of people, you need, in science, to define the action. And this is the foundation of this famous act, plan, do, check, dumbing, okay? Because you have the action of the tools, the action of the resource, the action of the people, and this is like Russian dolls. I am doing an action, plan, do, check, act, inside the system with doing action, etc. So I have communication between people. The problem is, do we understand the same way the action and the effect? The answer is no. Because if I am process guy, I have a blue glass on the world. If I have a maintenance guy, I have red glass. I don't see the same effect because I don't do the same action. So this is a big problem when you increase the number of products. You can't increase too much the number of machines, and you people are completely disappointed. The manager have to manage their innovator. The innovator thinks that when they have an idea, they will put in the box, and everybody will apply. Completely wrong. Okay? So, Deming say, if you want to manage that, you need to understand the activity as a system. This is why we have functional approach. He says you need to understand the variability theory. We did a huge amount of work like that. Data collection, computing, big data, okay? Everything of that is technology. ST was at the leading edge in this area. And we push, and we discover that we miss something. We miss that we have to understand what is knowledge and to understand employee psychology. And I will explain a little bit why. Because if you change the function and the activity of people, you change their culture, like was said. And you are obliged to take into account in the scientific approach how to communicate with the other. Okay? So, if I summarize, you have a market with a lot of products. You have advanced technology, high volume, strong price pressure, short lifetime. You have your function of the product and you want to manage risk. How do you do that? By making science. First, you collect data. You collect data where? Everywhere you can collect data. On the product, on the equipment, we are doing the function of the product, and the manufacturing. And why you do that? Because you want to manufacture. You want to do design for manufacturing, not only for the product, but for the maintenance procedure, for the machine, for everything you do design. And automation, quality, and lean manufacturing. If I summarize what is lean manufacturing, is right process at the right area. And because people are in front of a computer all the time, there is a new method. Please go back to the field to see what happens really. That's all. If you have to remember something in lean manufacturing, that's all. Okay? And second, what we do, we measure, we spend a huge amount of energy on that. Detection, detect raw facts, arrange data. Why? Because we want to have information. Because if we see this information, with information, we have symptoms, what we call failure mode. And we have effect of over quality and under quality. But here there is a big problem, and we miss that in the past, is the fact that the symptom depend of the glass you have. For the same measure, you don't see the same thing. If you take care of the cost of the parts of the machine, this is not the same thing than the product. And start the bubble tower at this level. Then, why do you do that with science? Because you want to do analysis and synthesis. Analyze, I cut in part. Synthesis, I move the part back. Eh oui, mais you need the value criteria to not have your symptom, meaning by understanding the cause. This is why we need PhD to understand, make science, standard science. But arrive something very bad for us. In the past, we do this way. And we have time when people have idea to give the culture to the people who design and execute. This is not true anymore. We have no time. That moves all the time. So we are obliged to treat something after knowledge, which is how to be sure that people will understand what I develop, what I put in at the execution. And this is not a knowledge problem, this is a competency problem. And I will move back to that. Because wisdom, the ability to use knowledge, you don't understand many times, the majority of the people who do the things, this is culture, they don't understand where the problem comes from. Even more if you change all the time the things. Because prevention, which is when I do the design of the things, is to be sure that I will not detect the cause. And this is the way we would like to manage the risk. And the problem is not anymore at this level. We spend a huge amount of money at this level, big data, to improve the analysis and synthesis. And now the problem is how to increase the speed of transfer of knowledge in culture. Okay? And this is the problem we have today. So, in order to link technical system and human actor without Babel Tower, how we have to do? If you look innovation, if you are unchanged, you are here. Incremental innovation, the more you are able to make a link in terms of vision and expertise, the more you are far from this point, the more expertise you want, and the more vision. So, if you have disruptive innovation, that means that you are far. The problem is how to make this innovation coming in your facility is a culture is not ready to receive. And that's what we are asking PhD to work on that. So, what we are doing, we say, of course we need new knowledge, but we need know-how. And I will explain the difference I put between knowledge and know-how. Then you need resource, human and technical. Because your innovation can be a technical one, your innovation can be to introduce new people, or new innovation can be new knowledge. Okay? And the majority of the innovation is not knowledge sometimes. It's just the ability to merge. So why is this different between know-how, human, and knowledge? Because knowledge can be, the know-how can be explicit or implicit. Explicit means you are able to share in knowledge. Implicit is the added value of the guy, of an organization. It just functions that you consult. You see? A big company like us, it's impossible for somebody or a group to know everything. So you are obliged to work on that. So that's why we are pushing more and more on competency. And competency is the ability to link knowledge, know-how, and resource, human and technical. And why we are doing that? Because, you see some text here, okay? They are coming from philosopher, German or the place, okay? Because they have worked a lot on this aspect. And they say how to ensure the point of view unity according to the way consciousness means principle, category, organize the reality. And this is what we need. People able to understand and to use this knowledge. So, a little movie. In our mind, when I have a problem, okay, we are not starling birds. I will show you a movie. Because we believe that I am here with my PhD or my group, I have a good idea, I put in the box, and people will use it. Okay? This is a starling bird vision, what I call starling bird vision. So I will show you a little movie with a summary of what we live on a daily basis. So you know starling birds? They have a project. Okay? Very nice picture. Huh? Okay, they are able to make different projects. This is not true for the plane, and sometimes it falls. But and you have never seen a flying bird killing another one. Okay, that works. And now you see other birds coming in the group without any problem, and they are individuals. Okay. So this is a way we see science, okay, but this is not the way it works, okay. And this is we are not starling birds. The rational process of scientific approach fits the process enlightening human reason in results in a rational pluralism, okay. Is it a problem? No. Because the complementarity of your rationality is useful. It's in physics, you know that there is relativity and complementarity. And I like Bohr because with complementarity, you can see something very precise. Okay? So this is what happened in natural and social environment where dialogue is ensured by significant symbols. You have groups. You believe that will go this way, your project, and this is not true. It goes this way. What is the size of the group? 2%. Okay, 2% working at the same time on a maintenance procedure and things like that. Even if they are highly educated, more if okay, after a few months, okay, they have ideas. They don't see the project the same way. But at the end, in an industry, we need something working. We don't need a bubble tower. So we need to work on this aspect, how to make science together. Because our factory, when we introduce an innovation in our factory, is like this place. Okay? Do you think that these birds understand the factory? The answer is no. This is symbols. Okay? And if you put somebody who have never seen this kind of place, he will be completely disappointed. And we see that when we receive some PhD for engineer arriving in our full manufacturing automated fabs, they don't know what to do. Okay? And you have somebody respecting the rules, the other not, but we can't introduce an innovation in this place and killing people or product. Okay? This is the problem we have. The problem is on this few modification. If you want to modify something, you have rules everywhere. The market asks us to change the product every 6 months, the technology every 2 months, and to have new things all the time. Okay? So this is the reality, and we have people to do that. So, meaning what? Meaning that we have to take care to the language, the symbol of mathematics. I like it. But we are not speaking all the time in mathematics language. We are speaking with symbolism, the process by which the mindset design a system of sign, learn how to use this sign, and substitute to the object. Meaning what? When we discuss, and this is my case today, if you understand 30% of what I am saying, I will be very happy. And is it a problem? No. You know things that I don't know, okay? But we have to have that in mind. Imagine the guy who was not there. Okay? That will be difficult for him. Why we believe that way is because we have two kinds of symbols. Mathematic, very nice one, and all the other. Dance, speaking, I don't know what you want, okay, painting. The difference between the two one is the rule for a mathematic symbol, sign, is fixed. As soon as you define it, 3 plus 5, okay, 8. It's true. 15th century, 17th century, 19th century, there is no story. The psychologos evolution, 0. Very nice to explain things, but this is wrong for every other language. If I use the sign telephone, this is the object. When I was young, this one, if you are in the night and you have telephone, you have a very nice group who the name is telephone, and today we have completely different object. This is the same name, same symbol, okay? This transition is true all the time. My father, before you have seen that you have people like that you follow, I like Bohr. So, what do you think? Do you know that? The Bohr atom. Do you know what Einstein said to Bohr when he shows this? You are inspired by God? And you know why? This is a very good mathematical system to explain what didn't work in the physics of the past, but Bohr knows that this object is completely wrong. Because if you take an electron, no light, turning around, electromagnetism, to the basket, this electron not moving on the atom, relativity, Newton, everything is removed. He knows that. It was just a form, symbolic form, ready to be seen by the people from the past because it's a planetary system. And during 10 years, they use to try to experiment about it, around it, you know? Because Bohr have a culture of language and knows that the symbolism is very important. Today, if you ask somebody what is an atom, except an equation, it's difficult to have a vision of the form. It's the same thing when we discuss all together. Okay? So we try to understand that, how to use complementarity when we do science. So, I will pass on that. So, if I summarize, when we receive a PhD, an engineer, and when we work all together, we have the transition from innovation genesis to industrialization. So I separate two words. On the left, the space system, the industrial system, the place in which relativity is very important. We need to understand the cause to effect, to reproduce. Okay? We need science for that, natural science. Okay? And we have data, give meaning, synthesis, and we have to take care to that. Wisdom. Then, this is the world, standard, organization, people who do the design and execution, the function of the product, the function of the tool who are making the product. To do that, this is the art of measurement. This is technology, object, nature. Okay? When you have ontogenes, you create something that people don't know, you do epigenes, meaning the cause effect, the understanding of the analysis. And that becomes a polygenes, meaning in the culture of the group. Nobody knows what it works, but some of them, but not all the people. The problem is, what happens when something is wrong on the system? With the system, you think only the system. And if you want to introduce something new, this is not on the system. This is on Genesis. So what happened? New idea. That was my case, the case of every start-upper. Okay, I have an idea. I explain to the other. To the third one. We don't understand each other. Okay? That becomes a nightmare. This is a symbolism issue. Okay? And now you have to create new links. This is not the art of measure. This is the art of psychophysics resonance. Okay? And you have to be, like was said, very confident with what you do. You need to believe in what you do to become an artist. Meaning experiment and error are not a problem. Error are not a problem because when you do science, you know that 80 to 90% of your experiments are going to the basket. But you learn a lot. Okay? And you have to do that because during this period, if you are well organized, we try to do that, you will collect knowledge, but you have to take care to competency. Because what will happen during this period, you will learn about, for each action, with who you are in relationship. Who is accountable, who is consulted, who is informed, and things like that. And the majority of the mistake we are doing today is we believe that we transfer knowledge. No, we transfer competency. The faculty, when I give my product to the production, to also transfer what is called RACI. RACI is a method to make people in relationship. Okay? And this is not true that you will transfer something that everybody is ready to realize. Sometimes they have to consult or to inform other people. Okay? So, to do that, where we are today on this problem. And this is a world, my feeling, this is a world in which you enter. Okay, a lot of companies are starting to work on that. Okay, we have last year a big prize in France on this kind of proposal. Okay, and we're using what is called SECA theory, is a theory of management, to manage incremental, disruptive innovation and competency. So we want to crystallize from existing competency and adjusting disruption while design with respect of rule-based design. What does that mean? That means that if you arrive in a culture, I used to work in different countries, and you try to use your own culture in the place, that doesn't work. Why are we doing that when we introduce a new product, a new concept, and things like that? Okay? We can do that when we go in another country, and we try to do that. And the difficulty, that when you arrive in a new country, that takes time. So, that's what we do. We crystallize to see what are the functions of the system. Then, we say, what is inside the system, meaning rule-based, that we can already use, which is existing. But not only the knowledge, the know-how, the resource, human and technique. Is there other way to move? If you do that, it's much more easy because the culture is already in your plant. It's a knowledge somewhere. You just have to transfer this knowledge for people for whom it's a concept. Okay? But because it's inside your culture, it's more easy. Then, when we have incremental or disruptive innovation, from the beginning, we take care to the skills. We see, where is innovation? Is it knowledge? Is it know-how? Like you say, I introduce a new guy, okay? Is it technical? This is completely different, okay? And the more you are wild design is not a problem, but the more you are wild, the more you need to take care about that. Okay? So we develop a technique, which is called SECA FMEA, to pass from here to here, to try to support the R&D and the innovation during the genesis phase. Okay? And the technique is, I will not enter the details, but we are interested by dynamic management and coherency of knowledge. So the first system is, we take care about what is knowledge, and is it shared? Okay? And as soon as we have done that, we take care about the new concept. And then, we take care about the wisdom. Okay? So we have a technique to do that, and the coherent management is ensured in terms of culture by minimizing the break of knowledge, maximizing the use of knowledge produced. And this is key. That's why when we have thesis students and we are in relationship with university, we try to share culture to be sure that we are able to coordinate the innovative behavior. Okay? So, to summarize the method, I will come back to startup and things like that. We have proposed a sort of organization and how to make the mission to be sure that we are not introducing Trojan horse. Okay? We are not putting in the system something who destroys the system. So, we create a long time ago, but we modify a technical staff college. And the goal is proto-epistemic society implementation, meaning that this is not going outside, that can be outside or inside, but proto-epistemic, this is a crystal, which is a new way of seeing the cause effect. Okay? A new sense. And we want to protect that. So we have a structure in triangle. Okay? Each time, this is at the company level. a board of philo. I'm chairman of that. And each time we have a project, we have an advisory board and the technical staff community, which is considered all the resources which have a competency in this domain. And why we do that? Because this structure we can do at company level, we can do at department level, we can do at every level, exactly the same structure. So this is the link, human. On the other side, we have the mission. We want to preserve and reorganize existing competencies. So how we do? When we know the triangle and focus on a problem, when we have a bubble tower, we put this guy together. So it's in French, but we create a space in which people are able to try, make error or things like that. But we oblige them from the beginning to follow the method with competency. Why? Because when they do the experiment, they highlight where we have to reorganize the expertise, how to reorganize the different organizations in which we will introduce a little part to make the system working. And we do that for another reason, is because during the process, we have the advisory board which supports, which convince, because this culture is moving at the same time as the process. And exactly like you said before, why innovation is not moving inside is because the people who receive didn't understand. They don't have the evolution. So we do that from the beginning inside the system. So the advisory board is here, and that's very powerful because as soon as you have this legitimation, so it's much more easy to deploy. Okay? So internally, we have a triangle also. This is a method I don't speak about who allows that, but we create a new entity versus what exists. This is what is called open lab, fast lab. So we have what we call an open lab, which is ST. The word of ST is not to have patent outside the scope, is to support customer. Meaning that we have a structure in which if people have good idea outside the company for product, we support that with government, with some local, area, with very easy support of the organization if the product, if we believe that that can be high volume production. This is external. Then for the product, we have another structure. This is in Rousset, in Grenoble. In Rousset, we have division. They have another structure with product, and they support university of people to see if there is new application. And this application, majority of the time, are given to our customer. And we create a new structure in Kroll, and this structure is to support start-upper inside the company. Meaning that it was very well explained, you have the spirit to be an innovator or not. This is true also to make a procedure of maintenance. So what we do, we have a structure in which these people, at the beginning, the management don't know, they start, and we follow them like startups. Business Canva, pitch elevator, and why we do that? To train people who have capability to be innovator, to be able then, when they come back to their organization, to deploy their spirit. You see? So this is what we do, and okay. So conclusion: to our knowledge-based organization, to have a successful transition, we need to go from knowledge-based organization on human science breeding ground. So you understand that for me, science is not only science of nature. Science of spirit is very important, okay? And Why? Because in the context of the industry 4.0 or X, the competency management has to support operational actor challenge, sharing expertise, creativity, competency, and this is true for every people of the organization. Of course, the customer, the supplier, the relationship with external communication, but everybody is concerned by that. And we need to turn from information-based organization, which was the dream of big data, to competence-based organization, linking technical system to human actors. And the competence of engineers and PhD, of course, from natural science, very important. I was, just to make a comment, I was one time, because I'm also teaching at university, with professor who say, what do you think, because you are coming from the industry, what do you think people don't want to learn equation? My answer was, if you do that, I don't come anymore. Because I can say to you that what is useful for me is my scientific background. Okay? So the people who say that, if they want to understand the feeling, the meaning of the thing, of course they have to read a lecture about science, but the foundation is very important. Okay? If you are superficial, after a few years, the works have no sense. Okay? Why I have patience today is because I continue to be interested by physics and things like that. Okay? Very important. And, okay. And to dynamically and currently manage knowledge, okay, human and technological, for living structure, genesis, to allow creativity and innovation to be expressed, and to embedded proto-epistemic approach, management and tools inside the organization. Voilà. And I like this Kandinsky and Einstein and Bohr because this is a summary. You know, relativity, the discussions they have between relativity and complementarity, okay? This is systemic, and this is to improve what we know in terms of relationship. Kandinsky works exactly on the same thing during his career, okay? The complementarity between things which are not clear and things which seems to be clear. Voilà. Thank you very much.